So now that you know how to convert pressures and volumes and temperatures, we can actually start our gas laws section. So gas laws are basically just a mathematical representation or relationship between volume, temperature, pressure, and the amount of gas present. So we're comparing V for volume, T for temperature, P for pressure to make our lives easier. So when you're completing gas law calculations, volume must either be in liters or milliliters. It doesn't matter which as long as you're consistent. Pressure must be in atmospheres, and temperature must be in Kelvin. So that's why it's important to know the conversions for each of those, because you have to be in these units to complete the gas law calculations. Okay, so the first law we're going to talk about is Boyle's law. So Boyle's law states a volume of gas varies inversely with pressure if the temperature is held constant. So we have V volume, P pressure, and T temperature. And you're going to have those for all. A volume of gas varies inversely, meaning opposite, with pressure, and temperature is held constant for Boyle's law. So this is the equation for Boyle's law. P1 V1 equals P2 V2. P1 means the original or initial pressure. V1 is the original or initial volume. P2 is the new or final pressure. And V2 is the new or final volume. Okay? So, just to kind of show you a visual representation, we have volume represented in yellow, and we said that gases like to spread out if possible. And we have pressure in the form of weights pushing down on the gas volume. And then down here, you have temperature held constant. So you can see when there's less pressure, the pressure gauge is down here, less pressure right there, more volume. And when there's more pressure right there, there's less volume. So it's an inverse relationship. So first gas law problem. Actually try these out. A sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atm. What will the volume of gas be at a pressure of 0.987 atm? Temperature is held constant. So we know we're using Boyle's law. P11 equals P2V2. Okay, I like to make a list, especially when you're getting started with these. I think it makes life easier. So P1 is 0.947 atm. Pressure is already in atm, so we don't have to change it. The initial volume is 150 milliliters. That's in the correct unit, so we're good for that. What will the volume be? So we're finding V2 in atmospheres if the pressure is changed. And that's also in atmosphere, so we're good. So I like to make a list. You don't necessarily have to. You could label it in the problem. So I'm going to take Boyle's law. And I'm solving for V2. So I need to get V2 by itself. So I'm going to divide both sides by P2. That cancels it out. So I'm left with P1 V1 over P2 equals V2. Now I can just plug in. Units are important, don't forget them. So P1 times V1 all over P2 will give us V2. So plug that in your calculator. 0.947 times 150, all divided by 0.987. And I get 143.92 in ml milliliters. 2 decimals if you can do it, please. Let's see if this makes sense. Pressure went up from P1 to P2. Boyle's law says if P goes up, V goes down. So if P goes up, V should go down. Did it? Well, yes, it did. It went from 150 to 143. So we are correct. Make sure you can check that. All right, next one. 2.5 liters of nitrogen gas at standard pressure doubles in volume. At what pressure does this occur? So once again, we're using Boyle's law. At what pressure does this occur? I'm finding P2, which means I have to divide both sides by V2. So I'm left with P1, V1 over V2 equals P2. Now I need to figure out my numbers. So liter is V1 at standard pressure. So we know this is P1, but there's no no number there. Well, what's standard pressure? Standard pressure is 1 atm. Remember STP. That's what I'm saying. I don't have to give you that numerical value. You should know that standard pressure is 1 atm. And then it says it doubles in volume. So I started with 2.5 liters. I'm doubling that. So V2 is 5. Now I can plug in P1 times V1 all over V2 equals P2. So 1 times 2.5 divided by 5. And you get 0.5 atm. Let's see if this makes sense. Boyle's law says if volume goes up, pressure must go down because they're inversely. Well, volume did go up. It went from 2.5 liters to 5 liters. Did pressure go down then? Well, we started at 1 atm and we went to 0.5. So yes, it did go down while volume went up. So once again, you can check yourself that way. Also, you could plug all of your numbers back into this equation. Sorry, I wrote it backwards, but it doesn't matter. Whoops. You could plug, oh my, I went so far. You could plug all of your numbers back into this equation. They should be very, very equivalent to each other. All right, one more. A balloon filled with helium gas has a volume of 500 milliliters and a pressure of 1 atm. The balloon is released and its pressure changes to 0.5 atm. Assuming the temperature is constant, what's the new volume of gas? So one thing to remember is there's never going to be any temperature numbers in the Boyle's law problems because temperature is constant. So once again, to start out with my initial equation, what is the new volume? So I'm solving for V2. Divide both sides by P2. P1 V1 over P2 equals V2. Now I have to figure out what's what. So V1, 500, P1, 1 atm, and here is P2. Let's just plug it in. P1, 1 atm, times V1, 500 milliliters, all over P2. And remember, if you're not in atmospheres or milliliters or liters, you have to convert, which we haven't done yet, but you will have to do eventually. So 1 times 500 divided by 0.5, and you get 1,000 milliliters for V2. Check and make sure it actually makes sense. In this case, pressure went down 1 atm to 0.5 atm. So pressure went down. If pressure went down, volume has to go up. Well, we started with 500 milliliters. Our final answer was 1,000 milliliters. So yep, that makes sense. Also, just because we can, let's plug back into this. So P1 times V1, that equals 500, equals P2 times V2. 1 times 500 is 500. 0.5 times 1,000 is 500. So once again, double checked. Yep, we're good. That is Boyle's law. Pressure and volume vary inversely if temperature is held constant. Therefore, temperature is not in the equation. So it's P1 V1 equals P2 V2.